Hello everyone. Today we're going to look at a problem involving simple mechanical machines. And one of the examples of simple mechanical machine is a system of pulleys, as the one shown here, where you apply a certain amount of force and you lift a weight, a given weight. So in many problems we assume pulleys to be weightless. But today we're going to consider both cases where the pulleys have zero weight. This is a simple case. And then we're going to consider the case where pulleys have a weight. That's going to be the second part of the problem later on. Okay, let's get started by reading the question together. The figure shows a system of pulleys. The weight of the block P is 120 newtons. Assuming pulleys are weightless, find the following. The minimal force F needed to pull the weight up. B. The rise of the block P when the rope is pulled by 12 meters by force F. Okay, so let's get started by drawing this thing a bit larger. Now, if you look at the system, what do we have? We apply force F here, right? So what does this do? Well, if we pull a rope by force F, the same force, the same tension force is transmitted along the rope down here. And this rope is connected here, so that means same tension force is transmitted here. So you're applying force F. Well, since this is a continuous rope, same force is pulling it up here. So what we have is 3F pulling it up, and this 3F is balancing the system. Since pulley is weightless, 3F is balancing P, or in other words, 3F equals P, right? So then, since we know the weight of the block, which is 120 newtons, all we have to do is apply 1/3 of the weight to balance this, which means the force needed to balance this is 40 newtons. I hope this part is clear. Now, let's look at the second part. By how much the block P will rise if we pull a rope by 12 meters? Well, if I pull a rope by 12 meters, that means this 12 meters has to be distributed along this rope everywhere, right? So you have rise by 4 meters, 4 meters, and 4 meters, and then this gives you 12 meters being pulled here. So the height by which weight P rises is going to be just simply 12 divided by 3, right? So you have 4 meters. Because if you pull 12 meters, 4 meters comes from here, 4 meter comes from here, 4 meter comes from here, so block lifts up by 4 meters up, and that gives you 12 meters of rope being pulled by force F. I hope this is clear to everyone. So these are the answers to the question: 40 newtons and 4 meters. Now let's consider a different case where pulleys now have a certain weight. In this case, pulleys are given to be 30 newtons, right? So let's read the question together. The figure shows a system of pulleys. The weight of the block P is again 120 newtons, and the weight of each pulley is 30 newtons. Find the minimal force F needed to pull the weight up. Okay, so what are we going to do here? Well, it's very simple. We're going to draw it again a little bit bigger. Let's label the pulleys 1, 2, and 3. So this is our first, second, and third pulleys. And again, we just apply the forces. We just write down the forces, right? So you have, if you're pulling by F, that means the tension here is F, tension here is F, and then tension here is F, right? So you have 3F pulling P up. So if you're going to write down the equation now, this 3F is balancing, see, balancing this system. So what does this mean? 3F has to be equal to the weight P plus weight of the pulley, which we call W. Okay, so a weight of the pulley 3, because F pulling these two things together. What does this mean? Well, F has to be equal to then P plus W divided by 3, or 120 newtons plus 30 newtons divided by 3. So force that we need to apply is 50 newtons. I hope this is clear to everyone, and that's the answer to this second question. Thank you.